Let us just remind ourselves the basics of trig, our ratios, all to do, of course, with this wonderful right-angled triangle is where we start. And then we named the sides, and we said, the largest side's the hypotenuse. Then we reference a particular angle, and the one next to it we call adjacent for obvious reasons, and the other one opposite, again, for obvious reasons. Which then brings us to our ratio. Sine obviously being opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. And then we have the reciprocal ratios when we flip these upside down, and I often think the person that named them was very mean in that cosec is the reciprocal of sine and sec is the reciprocal of cosine. Wouldn't you have thought it was more logical to go co with co? But no, this is the way they decided to name them. Alright, I'm sure there was a reason. An equation like this then, sine x equals cosine 25. I mean, there are lots of answers to this, but if we're just talking about a right-angled triangle, I mean, the co stands for something very specific. The co stands for complementary, and complementary angles add up to 90 degrees. That's why sine and cosine. In other words, what I do know is, as these are complementary ratios, the two angles must add up to be 90, therefore x must be 90 minus 25, it's got to be 65. Then you can apply that idea to something like this. They're complementary ratios, therefore those two angles must add up to be 90, and then we solve that equation. When it comes to right-angled triangles, there's really only three types of questions. One where we find a side that is not the hypotenuse, in this case a over 13 is tan of 61, we get an answer. One where the side we're finding is the hypotenuse, and in this case it's the sine ratio we're using. And the third case, of course, is when we have to find an angle in that right-angled triangle, and this is the cosine ratio this time. Notice I've used the inverse function notation there. So undo the cos, we do the inverse function, it's the inverse cosine function. And that's 44 degrees 25 to the nearest minute. But there are some ratios, our exact ratios, that we just know them straight away and write them down. We don't need to bother going to a calculator, we just, okay, let's write the exact value down. And they come from, the first one comes from this triangle where all the sides are 2. So therefore all the angles are 60. If I chop it in half, I get that 30-60 triangle. Work out the third side, it's root 3, and I can just read off that triangle the exact values. Sine 30 a half, cos 30 root 3 on 2, tan 31 on root 3, and then for 60 degrees, the sine and the cosine obviously flip because you've got complementary ratios there, and tan 60 becomes root 3. The other exact value we like is the 45 degrees, and that comes from an isosceles triangle, which means both of those angles are 45 degrees. We make the sides 1, the hypotenuse becomes the square root of 2, and we have our three exact ratios. Now how you choose to remember them, I guess, is up to you, but obviously they are ones we need to know. Here's an interesting way of remembering them. I don't know whether you've ever seen this before, but if I was to draw up a grid like this and write each of those values, 0, 30, 45, 60 and 90, something interesting happens. Sine has that pattern to it. Root 0 on 2, root 1 on 2, root 2 on 2, root 3 on 2, root 4 on 2, which simplifies down to be the exact ratios. Therefore cosine is the same but in reverse. And then tan, well, we know tan is sine on cos, and I get the tan ones. That's just another way of remembering. It's a nice little pattern as well. Measuring angles then. So we've got those word problems. How do we measure the angles and what have you? Sometimes it involves angles of elevation. And as the name suggests, that's when we elevate or lift from a horizontal. That would be the angle of elevation of B from A. So the wording of it's quite important, because if it's from A, that's where the angle is. We have angles of depression. That's where we lower from the horizontal. So this one will be the angle of depression. Again, it's from Y. That's where the angle is, of X from Y. And angle of elevation will always equal the angle of depression, because if you were to slide those two pictures together, you get alternate angles with parallel lines. Bearings. So compass bearings. North, south, east, west, which of course is where we get the word news from, because that's all the information from around the world, all areas of the compass. No, that's not actually true, by the way. It's just one of those urban myths out there that's where it came from. Okay. Then we can break it up into subdivisions. If we equally divide that, we get northeast, southeast, and so on. But you could divide it again And when you're naming them, you always go with the major one first. So this first one up here, north would be the more major one, so we'd go north, northeast, and so on. And look, theoretically you could keep going, but it starts getting out of control. But theoretically, if I was to go halfway between north, northeast, and northeast, well, the more major one would be the northeast, so it would be northeast, north, northeast. But as I say, it starts getting out of control, so we tend not to do that. And that's why we have true bearings, where we simply go, oh, well, look, we'll start at north. How many degrees have we gone round in a clockwise manner? So there's X and Y. If I want to work out the bearing of Y from X, that means the angle is at X. Let's put it there, and let's say that angle's 30 degrees. If I measure from north, then it would be 120 degrees. It's a true bearing, so often we put T after it. But the other key thing about bearings is it's always 3 digits. 3 digits. If I wrote it in reference to the compass points, then I would start at south. We always write it as an acute angle, and you start from either north or south, so it's south 60 degrees in the east direction. If I did it the other way around and said, well, what is it from Y? Now I could, bit of geometry, I know that angle is going to be 60 degrees. The true angle becomes 300, and that would be north 60 degrees west. Now in 6A you'll see I said pick some, because it really is just an exercise in, hey, do you know how to use your calculator? I'm sure you all know how to use your calculator, but if you want to try some, by all means, go for your life.